Hello everyone, welcome to my channel Analytics Bot, and today we will be talking about machine learning with H2O and Python. I'll just talk about this is the agenda that we have. So I'll talk about me, and then we'll talk about H2O, the H2O architecture, and then the machine learning algorithms in H2O, and then we'll just go into hands-on with H2O and Python. About me, I have bachelor's from IIT Roorkee, and I'm currently pursuing MS in Business Analytics from UConn. I have around 4 years of experience in the analytics field, and I worked with Python or Java. And this is my email, and this is where I can be contacted on LinkedIn. Let's talk about H2O. So what is H2O? If you have been working on big data platforms, like for example Hadoop and Spark and all those sort, this is the entry in that domain, but this is strictly in the machine learning domain. So with Spark we can do a lot of data transformation and data aggregation and those sort of things, and we can also do machine learning. So it's basically a solution for starting from data wrangling to data preparation to machine learning. But here what we have with H2O is it's basically it's strictly a machine learning platform. It's very fast, it's scalable, and it's open source as well. So what H2O uses is it uses in-memory compression, and which can handle billions of rows of data in very small amount of time, and it's scalable. So if you have been using Python with scikit-learn, you have been one of the limitations is the size of the data. So it has to fit on a computer. We can't scale scikit-learn machine learning or maybe carrot machine learning and R to multiple nodes, but with H2O this is a piece of cake. So how H2O deals is, even let's say there are H2O there's an H2O installed on multiple nodes in a on machines in a cluster. So what H2O will do is basically it will find the similar nodes and auto connect themselves. There's also settings that we can do that basically will connect themselves. For example, what we do in case of Hadoop or in case of Spark to set up the cluster, we basically give the node addresses and so on. Also here there is no concept of a master node, and H2O can run on top of Hadoop and Spark as well, and it can get the data from HDFS. It has very compatible APIs with R, Python, Scala, Java, JSON, and like other technologies, this is also designed to run in a standalone mode or within other environments I just talked about. One good thing also about H2O is they're also bringing out deep learning on top of this, and this is the website. If you are if you want to look at, you can just go and check out the website. So let's quickly take a look at the H2O architecture. So as I said, H2O can take data from variety of sources. It can also take data from Hadoop and Spark. Basically, if the data is on HDFS, it can pick up the data. If the data is on Spark or in RDD, so that can be converted to H2O data frame, as we'll see later when we do a hands-on. And then basically we have the memory manager, and then we have the different ensembles. They have clustering techniques, classification, regression, trees, boosting, forest, solver, and gradients. So basically H2O was one of the first companies which came out with the gradient boosting machines, or GBMs as we know, in a scalable manner. It has a really good API that we talked about with R and all those things. In addition to this, we also have something called Flow, and Flow is basically a front-end UI for those who don't know much of programming. So as I said, basically some of the common algorithms are machine learning, and these can be scaled: naive Bayes principle, PCA, k-means clustering, and others. It also has sparkling water. Basically it's nothing other than H2O running on spark. It also speak on deep water, and these are basically deep technologies for deep learning libraries on top of H2O. So I think we have talked enough about H2O. I would basically you know uh, mm, uh, go into the hands-on exercise. So we'll now open the IPython notebook, and below this YouTube tutorial you'll find a link to the GitHub repository from which you can download the data and the IPython notebook. The data that we have taken, we'll working on, I have taken is is the marketing data set from the UCI machine learning web repository, and this is the link that to the problem. It's a classification problem, and the goal is to predict if the client will subscribe to a term deposit or not. So let's get started. So I have started the IPython notebook here, and I'll basically open it. We also have the data, and I have the PPT that I was just talking about. So the first step is basically to install H2O, and it's very easy. If you have ever installed any module in Python, it should be a piece of cake to you. So all we have to do is pip install H2O, and this will install H2O, all the required files. Now keep in mind that H2O is made in Java, so you need to have Java 7 or 8 installed on your machine. So since H2O is already installed on my computer, so it's saying requirement already satisfied, but for you it will give an obviously a different value. It will install it for you. If there are some errors, you can use Stack Overflow to check the errors, but I hopefully it should go through. Make sure that H2O is installed. The only problem that I see is you might not have good memory left, or Java is not installed on your computer. You can do pip install H2O. If you don't know about pip, I would suggest to you just basically Google how to install pip for Python. It can also be installed from the latest repository, the H2O repository. So I also read that the H2O repository is currently it's maintained, but on PyPy it might not be in the up-to-date version. So I'm assuming that you have installed H2O, and the first step is basically to import H2O, and depending on the now it's installed as I said. So the first step is basically to initialize H2O on the machine, or basically to start H2O cluster, the standalone cluster on this machine. And what this will do is basically this IPython notebook, whatever we are running. So I'll just take a brief example. Whenever we run some commands in IPython notebook, what it does is basically it goes to the Python server that's running on this machine, and all the things are executed there, even if you're doing scikit-learn or reading a data set or doing some transformation. In case of H2, what will happen is whatever commands we are running here, it will go to the H2O Java virtual machine or JVM that we have, and everything will run there. Nothing will run on the Python execution framework. So once we run this, there are again different ways to run this. We can basically, let's say if your H2O installed on a separate machine in the network, then we can define the IP and the port number. We can, by default it's in threshold -1, and we can give how much memory should the machine use. Right now I've given whatever memory available, please use that. And it's advisable to basically remove the running clusters if there are, if you are starting a new program. So it looks like it gave me some error. It always gives me some error, and I think that's because I have low memory. So if you're like that, basically what you have to do is basically you have to run this command again, and then this will successfully execute. So as we can see that now there's a H2 instance running on this on this port and IP. So I'll just open that to see. Okay, it's not opening. I'll just do a copy paste and hopefully that should work. So this is the front end that I was talking about. This is called H2O Flow, and we have different options: import files, get frames, split frames, merge frames, get models, all those things. It's basically for the beginners, or if you don't have any programming experience. So we can do all sort of things. We can basically create a flow and then do all the machine learning on that. But I will not be covering flow for this tutorial. I'll be directly going into Python, and these are the different things that the different parameters for this session. So the run, it just started 25 seconds ago. This is the cluster version. This I installed H2O 2 months ago, and all those things. It has around 1 GB of RAM that it can use for all the processes. So let's start basic really. uh, so if again, I'll from time to time you'll see me drawing parallel uh, between scikit-learn and H2O, because what H2O folks have done is they have uh, made it quite similar. And at this point of time you might have a question: okay, why not I use scikit-learn instead of learning something new? So for that I'll basically have two things. There's no learning curve. If you already know scikit-learn, they made it quite compatible. Even the APIs and the declaration that they have, that's quite similar to scikit-learn. And second is scikit-learn at some point of time will give up when the data increases. But what H2 what it scales your data. You can there's no limit actually uh, to the number of clusters, number of nodes, or the size of the data that you can scale this machine learning activity to. Couple of downsides is basically there are more algorithms that are available on scikit-learn as compared to H2O, but I think that's mostly because the not all algorithms can be scaled to multiple nodes. So this is similar to the so whenever we use scikit-learn, basically we use pandas to load the data set, and then we provide the data set to the APIs. Here we it's an end-to-end flow. We'll see how to load a CSV or other source data from data frame as well. So here what we'll do is basically we will initialize H2O frame, and what it'll do is basically it has three columns: 1, 2, 3 ABC and 0.1, 0.2, 0.3, and we'll see the data frame. I'm using Python 2.7. So whenever you don't specify the column name, it will by default take C1, C2, C3 for column 1, 2, 3. And then this was the tuple that we worked with. So this is a Python tuple and this is a Python list, and what happens is this then goes to the Java virtual machine that is running H2O, and then the results are calculated there and then brought here. And also what's happening is this, you'll see a nice progress bar. So this is one of the things that I find missing in Python, especially with using scikit-learn. So I have to wait and I have to see the star, or maybe I'm using idle or PyCharm. There's no definite way of knowing okay what my program is doing. Here I have a past progress, although you can basically turn that off. This is a feature. I won't recommend it. So this is a cool thing that I really like about H2O here. Now one more thing that we can do is basically we can initialize using a dictionary. So it's the same thing, but now we have the flexibility of giving the column names to our data set. And there's one new command that we will see is called df.type. It will basically give the data type of each of the columns. In Python pandas, it's as d type that will give the same, and it does a little bit differences, but not much. So again there's one more thing that we can specify. This is time column. This is again missing when we deal with pandas and then with scikit-learn. Here what we're doing is we're initializing a random number from of 100 rows and 4 columns, and then we're giving A, B, C, D as the column names. And let's see the top 10 rows. So by df.head as same as Python pandas. It will give the top 10 rows, and if we want to see a lesser number of rows, then we can specify. So by default it's 2. If I give here 2, then it will just give me the top 2 rows. So it's the same. It's the same and is for tail as well. So I won't delve deeper. To get known to get the name of the column names, it's just div the columns, and to describe, it's basically div the describe. And this again is a really cool thing here. It gives a brief and idea about what this is. Basically mins, max, sigma, minimum, mean, and how many missing values are in each of the columns, and how many of them are zero. So this is what we get, and then we can subset the data same as we can subset in pandas, so nothing different here. We can subset by more than one columns, B and C here. So for dealing with missing values, it's almost the same thing as the subsetting is quite easy as well. While dealing with missing values, it's quite the same as working with Python pandas. So here what we do is we basically initialize a data frame with some missing values, and we can see the missing values are NA here. And the next is we can see that how many missing values are in this basically. So we can say the first one has 0 missing values, and so on. So this is comparing row wise. So we have to see the first of these columns, first of these elements of each of this list, and we can see the last two are having 1 1. So basically this is considering the NA as the missing value. The space and nuns are not considered a missing value here. So what we can do is basically we can assign the missing values in column A to 5, and this is done using this command. So what we are doing here is basically we are taking column A, and then we are checking, okay, if the value is if the particular value of the cell is NA, then what we do is basically we this gives the index, and then this specifically is for column A, and assign that to 5. And now next, if we check if there are missing values in column A, it will give us 0. Before it was giving us 2 missing values. We can also calculate the mean. So it will basically calculate the mean using NA is removed, obviously. The next is basically the apply function that we have in Python. Is the same here as well. So what we do is basically we initialize a data frame using a NumPy array with 100 rows and 4 columns. And the names are A, B, C, and D. And what we do is basically we apply the mean function to each of these elements. So using the lambda function or the anonymous function, if somebody might say. And then if we check the type of this, we'll see this is basically a H2O frame that is being given to us. If we directly apply the mean function, then it gives the same result, and it's of the type list. So I will suggest whenever you're using apply function, it's highly optimized. Then we can apply some other functions. So basically this is the row wise sum that we can do, and so the axis is 0 for that. We can also perform column wise sum as well. There are some really cool string functions that I think I'm seeing in scikit-learn or maybe pandas. So what we can do is we initialize this H2O frame. So you'll always find a concept of H2O frame when dealing with H2O. So here this is a string of hello world, welcome to H2O world, and all those things. I took this example from the H2O documentation on their website. So the next is basically the number of L's in this document are basically in each of these columns. Each of these values is basically 2 1 1 0 1 1, and we can see there are like 2 L's in hello and so on. So this is a good thing. We can also substitute a particular letter with X with another letter. So here I substitute L with X, and now it's hexlo. Now keep in mind that it will only substitute the first occurrence and not all the occurrence. So like for example here we have hexlo instead of hexo. Let's go to the merging of data sets. So here what we're doing is we are initializing two data frames with numpy arrays, and what we'll do is basically, since we have the same column name, we can then join on, similar common names. So let's initialize that. It's quite quick. And now here there's a slight change with Python pandas. We have rbind and cbind. This is quite synonymous with the data frame concept in R. So this is very good. I think again this is missing in Python. I don't know if they purposely left it or not, but I find this quite intuitive. So rbind we can do so, but we'll usually stack the two data frames on rows. So we have like A, B, and C, D still. And if we do a cbind, it will basically stack on columns. So we see the df1 is here, and then df2 is here, and then since the columns name were same, so it assigned a0, b0, c0, and d0. So the next step is basically merging the data frames. So if we want to merge the data frames, what we can do is we can simply use df2.merge df1. This is quite the same as in pandas as well, so no difference there. We can also do group by operations. This is quite the same. So what we're doing is we are declaring H2O frame using dictionary, Python dictionary, and then we are grouping on A. So in A we have foo, bar, foo, bar, foo, bar, foo, foo. So what we'll do is basically there are two unique values, foo and bar, and then that's what we'll do is basically sum based on the columns, column A. So here we'll have bar. For bar we have all the sums of C, since it's an numpy array. Now it's the same for foo as well, and for B, which is categorical variable, we have the sum of unique values in that. So we can see that that's 3 and 5. So you can see for foo, like there are 3 values thing. The same, we can calculate the mean, we can calculate min and max, we can group by more than one columns as well. So that's quite intuitive here. Again really cool thing that with H2O is the compatibility with date. So H2O is quite compatible with date. So here what we have done is we have declared a H2O frame with a column name D, and these are the values in that, and the column type that we have put is time. What we can do is we can basically get out the day and the day of the week from this column. So here we can see that the day is 80, 90, and 20, and the day of the week Sunday, Monday, and Tuesday. So that's enough for talking about simple concepts. I was just trying to draw a parallel between Python's pandas and mostly pandas still here and H2O. So now we'll be talking delving dive into the machine learning thing. So as I talked about, H2O supports the following models as of now. So deep learning, naive Bayes, PCA, K-means, generalized linear models, data boosting machines, and distributed random forest, and some other models as well. So we talked about the problem statement here. So we will be doing classification exercise, and we'll be using 3 different APIs. So just looking at this, I'm quite sure if you have used scikit-learn, you can draw the parallel here. Here we have what we're doing is from h2o.estimates.gbm, that's gradient boosting machine. We are importing H2O gradient boosting estimator. Is the same that we do in scikit-learn. So the API that's are quite compatible. We are also importing GLM, that's basically the logistic regression that we often talk about. Then we also import the random forest estimator. Now remember, all these algorithms are highly optimized for cluster mode. So if you have one standalone cluster, or if you have multiple clusters, it will perform the same. Then what we also do is we also import the H2O grid search. So this is quite similar to the scikit-learn's grid search. What it does is basically for any machine learning library, there are different parameters that we do. So it basically optimizes the parameters so that the accuracy is the best or the error is the least. Uh, so the next step is basically I'll just read the data set here. So you have to basically provide the path of where the data set exists. So here H2O provides end-to-end framework. It provides the import file as well. So that's what I will do here. So it also showed me the password. If we are using scikit-learn, then you have to use read.csv from pandas to pass on the data frames to scikit. But here what H2O has its own API, and I think that's mostly because it will try to optimize the data set here itself. So it will try to compress it so that it can be used later in a fast manner. So we can check out the first 5 rows. So we have the age, so this is a categorical variable, continuous variable. We have job, so that is a category variable. So marital status, that's also a categorical variable. We have education and default, whether the person defaulted before or not. Balance, housing, loan, contact, day, month, duration, and all those things. So let's look at each of these variables. So age is a numeric variable, as said. We have a continuous variable. Job, type of job of the person, marital status, education, default, has credited in default or not. These are 2 values, 3 values, no, yes, and unknown. This housing, whether the person has housing loan or not. It has again no, yes, unknown. Whether the person has personal loan or not. So you can read through all the other columns that we have here. And the output values is, has the client subscribed a client term deposit or not. It's a binary value. It has yes and no. So basically we have a binary classification here. We can check the data type of each of these columns. So we have see that age is int, balance isn't, and so on. One more thing that we can do here is basically we can, here it's not possible, but in any given case, if if you want to convert that from a numeric to a categorical variable, we can do a last factor. This is something that we quite see when we are dealing with R, but when dealing with Python, that's missing. You can also see the levels. So levels is nothing but the values in that particular column, the unique values, reverse, married, and single in that particular order. So here the order matters. So right now it doesn't matter, but the levels, what does that means? We can see we can describe the data frame that we have here. So we can see the type of the columns here. We can see the minimum value, the mean value, maximum value, and the sigma. That's a standard deviation. And keep in mind these values only come for the numeric column. So we can see these are missing for the category variables. This is also called enumeration. So when dealing with any machine learning task, we divide the data into 3 parts, or sometimes or at least 2 parts. The 3 parts are basically the training set. So this is the data on which on the algorithm learns. It learns how to basically do its task. Validation set is basically let's say when we train, we use the validation set to avoid overfitting. And overfitting is something this happens when the algorithm starts to model noise as well, and we don't want that. We want that the models should generalize very well when working on unseen data, and the unseen data is called the test data, and this is the data set on which we find the accuracy and see the output. So what we'll do is basically we will split the data, and then there are 2 methods of splitting the data that this H2O provides. The first one is basically using the frame API, and then we can give the ratios for this is the training set, and this is the validation and the test set. So all 70 plus 15 plus 15 will add to 100, and this is the seed one, that this is basically make sure that when you repeat the experiments, or when you pass on the notebook to someone else, they all get the same results. And then we basically get the data from using splits. The second is basically using this, it generates a random number between 0 and 1, and we see that wherever it's less than 0.7 we consider that as training set, and then wherever it's greater than or equal to 0.7 we consider that as the training set. I always use this. You can also use this. So let's check the shape of the data. So we can see there are 17 columns in each of these, and then we have 31,680 rows in training data set, and then 13,531 in validation set. So first we'll be implementing gradient linear estimator, or GLM. So we can read about the documentation using the help command. So there seems to be some error. I'll see what happened. Might not have imported it correctly. It looks correctly imported. I'll just import it again. I don't know why that happened. I have imported this. Okay, I don't know, something happened. So this is the documentation. We can read about the class definition and the methods that are available in this API. Since we talked about this is binary classification, we just see the unique values in this. So we see there is no one, yes, so that's a binary classification. So here is how we are building model. First we initialize the model. So it's a GLM model. We initialize using a binomial function, and the lambda search is equal to true. So lambda is basically it controls the amount of regularization. Now I just talked briefly about regularization. When we are building any linear model, whether it be linear regression or simple regression, what happens, or be it any model, what happens is the coefficients of each of these parameters, sometimes they are too big, and we don't want and this basically signifies a little bit of overfitting, and we want to basically avoid overfitting, and that's where the lambda parameter comes. This basically penalizes the weights that are beyond certain level and are huge. So lambda controls the amount of levelation in the GLM model, and we can find the optimal value of lambda automatically by setting this lambda search is equal to true parameter. Now here comes a reference. When we are working with scikit-learn, what we mostly pass is the actual data frame, but in case of H2O frame, what we do is we pass on the column names, and we don't actually pass on the data set. We'll see why. So I'll just store the predictors. These are the columns that we are using to predict the final variables, and the response is the final variable, whether the person registered or not. And then we use the train method that's available, and this will basically train the model on the predictors, the response, and the training data frame H train that we talked about, and the validation is valid. And this is what we just talked about. Let's see the GLM model. So here are different metrics for this model. This is a general linear model that we talked about. This is the MSE, RMSE, log loss on the training data set, and we'll see the same metrics for the on the validation set as well. So one thing we have to make sure is the error rate should be comparable on both these data sets. They should not be quite different. Otherwise, that's a traditional case of overfitting of data. We can see the accuracy, the AOC, the confusion matrix for our data here. So we see that the accuracy is on 31.1% and 90.41% for each of these two classes we have. The overall AUC is 0.909, which is okay. In the confusion matrix we can see here, so what we did is basically we correctly classified 2, 5, 4, 3, 6 no's and no's, but we incorrectly classified 2, 5, 2, 3 no's as yes, so around 9% of error rate here. So we can again use the predict API to make the predictions on the validation dataset, and we will only pass the last one. So here we see we are doing pretty good on the prediction part, like no, these things. So next we train the model, and we can we just basically so this is a GPM that we just imported, and then this is the gradient boosting estimator. This is a binary distribution because it's a logistic regression that we're doing, and the default values are number 3 is 3. It will go to the maximum depth of 3. Minimum rows that should be done data is 2, and the learning rate is 0.2. Although I generally go with 0.01, but I think we don't have too much data, so 0.2 should work. The number of folds that I'm working with is 5 here. The general number of folds that we work with is 5 or 10. There are people sometimes, this is the hyperparameter that sometimes you can optimize this. So we instantiated the GBM, and now we are training the GBM. As we can see, it's giving us the progress here. It should be done pretty quick. We can see the same metrics for the data. So we can see the accuracy scores, the AOC, and we can see the using GBM has increased our AOC score to 93.62%, which is a really good as compared to a simple GLM model. We can also do a grid search on this. So grid search, as I said, basically we can try to these are all the hyperparameters. The number 3 is the max, the learning rate. So what we can do is we can pass on the values for this, and what H2 will try to do is H2 grid search will try to optimize among these parameters. So it will take all the possible combinations between these values, and then the whichever value as the best accuracy will be given out. So now it's building the model. It will take some time, and we can also see that the strategy that we have given is random discrete, so randomly see, and the maximum runtime is 60 seconds for the model. You can play with all these parameters, and then you can basically go to the documentation to see what other values we have. Just quickly see that. Okay, it's too on top. So my research, okay, I have not given the documentation here. So I think it has run, given 100%. Let's see what GS has. It will have all the possible combination that it tried, and then what is the log loss in this. We can basically sort this by decreasing order and get the best model out of this. And let's see the AOC score. So it's 93.41%. So this is not good as compared to the before value. We can also initialize a random forest estimator using these values. So here uh, we giving again number of folds as 5. This is model ID that we give, number of trees, the maximum depth, stopping grounds, stopping tolerance, score each iteration is equal to 2. We can read about these hyperparameters, and then we can train the model. So it will take the time. And one good thing with random forest is we can see uh, which of these variables have higher importance. So we can basically calculate the higher importance, which is the next one. And this it will take time, so it will try to build all these trees and then do the ensemble of trees among this. What random forest, you can read about random forest. So it will basically take sample of the data, build a tree on that. It will also take the sample of number of columns and then build a tree on that, and then at the end whichever trees work best, it will make an ensemble of all those trees. uh, so it will, in total it will build around 200 trees. So what I'll do is basically I'll just pause the video, and then once this model is built, I'll start again. So the random forest model ran, and we can see the variable importances here. So uh, these are the various importance scores. The duration is the most important that we can see, and we can see the accuracy score here as well. So it's around 90%. So GBM worked the best among the three models. So this was a brief overview to give an idea how to do machine learning on top of H2O, and I hope that this might have helped some getting started on the H2O platform. So at the end, when everything is done, we'll just shut down the H2O platform so that the session is closed and memory released. So thank you, and thank you for watching the video.